So I'd like to welcome everybody to our webinar, SaferSim webinar entitled The Effect of Roadside Vegetation and Clear Zone Design on Driver Behavior. Our presenters today are Dr. Mike Knodler and PhD candidate Cole Fitzpatrick from the University of Massachusetts at Amherst. So I'll let you guys take it away. Mike, are you still there?
Cole, are you there?
Yeah, I'm here.
Hi, Cole.
Mike, I think we're not seeing you as having an audio connection right now.
All right, so I'm getting some text messages from Mike that he's having some technical difficulties on his end, so I'll just pick it up and wing it on the fly here.
Okay.
So thank you, Dawn, for the introduction. So I'll go ahead and get started. So for those of you who were able to hear Mike for the first time, this may be a little bit repetitive, but SaferSim is a consortium of 5 universities, with UMass being one of the primary, or not one of the primary simulator schools, obviously, one of the 5 universities, led by the folks at University of Iowa with their NAD simulator, University of Wisconsin, Central Florida, and then University of Puerto Rico, Mayagüez. So UMass is located in the western half of the state, contrary to some popular beliefs. We're out in the middle of nowhere. A beautiful campus, especially in the fall time. And then picking up where Mike left off, here at UMass, we really combine the human factors and the driving simulation expertise with some of the traditional traffic engineering expertise, such as the safety data warehouse. So in a lot of our projects, we combine some traditional traffic engineering and safety analyses, and we take those findings and design a simulator experiment to try and supplement those projects. So with this specific project, we really wanted to investigate the clear zone. So we just kind of have a silly graphic here that shows why the clear zone is important. So it's defined as the area along the roadway to provide recovery for errant vehicles. So you can see here if a vehicle were to run off the road in a large clear zone, this might not be very severe, but in a small clear zone, this could result in a very deadly crash.
Cole, can you hear me?
Yeah, Mike, you're back.
So I just wanted you to do the tough introduction part.
Oh, yeah, thanks.
So, no, actually what it was, it looked like I was showing up in 2 different places because of the phone and the web, so I had to manually unmute the phone one here. But so I'll jump in and take the next slide if you want here, Cole.
Sure.
So I think Cole set up the stage, and our hope is to take the next 20 minutes or so and outline some of the work that we did in and around the questions surrounding clear zones. And so, you know, when we think about the literature, there's really 2 common threads here. One is that there's positive psychological implications from roadside vegetation. Reduce stress, decrease road rage, alleviates depression. There's certainly some advantages that come along with presence of vegetation on the side of the roadway. Yet at the same time, when we think about run-off-the-road crashes, we know that run-off-the-road crashes involving trees have some of the worst severity, and we certainly know the outcomes of those. So we think about the pros and the cons, and then we wanted to say, well, when we put those together, how does the density of the roadside vegetation affect driver behavior, and how does the size of the clear zone affect driver behavior?
We had it before.
All right, so I'll go back. I'll pick it up from here again. So we approach these problems in 3 different ways. So what I'm going to do is explain each method and then the results we got from that method. So the first one was a static evaluation. So what we did was we collected videos from the driver's perspective at 8 locations around Amherst. So these 8 locations had varying clear zone size and vegetation densities. And then what we did was we also collected videos from some simulator scenarios that we built with the same roadside configurations. And then we took these videos and presented them in an online static evaluation, which we distributed to over 100 participants across the country. And the primary question we asked them was, what speed would you travel on this roadway? And the responses definitely varied, but we really saw some differences in the responses from the videos from the real world drives captured in Amherst. So when the clear zone was large and there was vegetation, people indicated that they would drive at higher speeds than when trees were closer to the roadway. Now we didn't see these same results from the virtual drive videos. And this could have been for a variety of reasons. One being that simply watching videos of a virtual drive may not have been as immersive as actually participating in a simulator study. So this fact kind of pushed us or motivated us to do a full simulator study, which I'll explain in a little bit. A second component of our experiment was to collect data in the field. So using video and a LiDAR gun, we captured speeds and lateral positions from vehicles. Now these 2 pictures here are kind of just an example. We're a little more conspicuous than this, but this just gives you a sense of how data collection was conducted. So from the videos, we're able to analyze the lane positioning by using a grid. So this allowed us to compare a vehicle's position relative to the edge line in a constant manner. So we did it the old school way with a transparency and tape on the computer screen. And recently we discovered a program called Knodler. And what that program allows you to do is to project a virtual grid onto the screen. So it's very easy to be consistent. Now, with the field data collection, we captured a vehicle upstream and downstream. And this was in order to track the vehicle's position and speed as the roadside configuration changed. So in this example here, the roadway went from having a large clear zone with no vegetation or sparse vegetation to a large clear zone with dense vegetation. So in this example here, when the dense vegetation became present, drivers moved further from the edge of the roadway, but we didn't observe a significant difference in their speeds. At a second location, the density of the vegetation maintained or stayed constant, but the size of the clear zone increased. So here, when the clear zone increased, drivers moved closer to the edge of the road because they're seemingly more comfortable. But contradictory to our static evaluation results, drivers slowed down in the presence of a large clear zone. So this maybe suggested that other variables were at play on the roadway, and this further reinforced the need for a simulator study to really hone in on the variables and keep everything constant except for the roadside configuration. So I built up to this, but we did conduct a simulator study where we varied the vegetation and clear zone size. Let's see, I'm getting an echo here, hold on. Oh, thank you, Ryan. Okay, so our three performance metrics were speed and lateral position, and this time we also tracked visual scan patterns or driver's eye movements. We had 24 participants with 12 males and 12 females, and then we tested 6 different combinations of clear zone size and roadside vegetation. So for each of these 6 segments, they were comprised into a module, and within that module we analyzed the participants' speed and lateral position at 8 different locations, and this allowed for easy comparisons. So the speed in our simulator, the speed and lateral positions are captured continuously, maybe 30 times a second. So by using fixed analysis points, it was easier to work with the data. And then we used a Latin square design to counterbalance the scenarios. So that way, not every driver experienced the same segment in the same order. And then, as I mentioned, we captured speed and lateral positions and scan patterns using a mobile eye tracker. And the picture on the right here shows an example from our drive with the driver fixated on the speedometer in this specific moment. So getting into some of the results from our simulator study, so we compared drivers to themselves. So what that means is we took a driver's speed and lateral position at one point within a roadside configuration and compared that to that same driver's speed and lateral position within a different roadside configuration. So this resulted in means that were at the surface don't appear very different, but this method of analysis did unveil some significant differences, which I'll highlight here. So the first was on tangent segments, drivers or participants drove faster in a larger clear zone as compared to a smaller clear zone. In a smaller clear zone, they positioned their vehicle closer to the center line than in a medium clear zone. Along right curves, we didn't see any differences, but along left curves, drivers drove slower in small clear zones as compared to medium and large, and similar to the tangents, drivers positioned their vehicle closer to the center line when the clear zone was small. So these findings were consistent with our findings in the field data collection and the static evaluation, and they were consistent with some of the literature previously. So this comparison is for the clear zone width, and I don't have the table for the vegetation density on here because there were really no significant differences. And that was kind of consistent as well with some of our previous work. So I mentioned the eye tracking previously. One way we utilized that data was by looking at the glances at the speedometer. So by looking at the glances of the speedometer, we could kind of analyze how comfortable a driver was with the driving simulator based on how frequently they were checking their speeds. And in this table here, these are the coordinates or the y-coordinate of the driver's glance. So it's pretty obvious to recognize when they're looking away from the forward roadway. So what we did was we looked at the number of glances at the speedometer based on where they were in the experimental drive. So if they were in the first module or the very last. And we found that drivers paid less attention to their speed towards the end of the drive. So with our 24 participants, we did do a 10-minute warm-up period before the experimental drive. And this was intended for them to become familiar with the simulator, and this is just common in general for simulator studies. So what these data here kind of tell us is that perhaps 10 minutes wasn't enough, and that a longer warm-up period would have resulted in more homogeneous driver behavior throughout the simulator study. Now, earlier I mentioned the counterbalancing and the Latin square. So because we varied the order of the roadside configurations, this probably wouldn't have affected our results. But it's still interesting to note. So if Mike is still with us, I'll pass it off to him.
Yeah, and I'll take over, Cole, and I hope everybody can hear me now, and I apologize for the technical difficulties earlier. One of the things that I wanted to mention in the intro and sort of some of the motivation behind why we were doing this is tied to the conversation that happened a couple years ago, where we were talking about what happened when we increased the clear zone on a roadway. We suspected that the speeds on that roadway were increasing, and that, you know, as the speeds increased, the need for the clear zone increased, and as the clear zone increased, the speeds increased. And it became a little bit circular, but we didn't think that it would continue to increase significantly beyond a certain point. And we also wanted to say, well, okay, well, in absence of trees, is it possible to put shrubbery or something that wouldn't be as harmful on the side of the roadway that would still provide a net effect that would allow us to manage or calm or reduce speeds and still see some of the behaviors that we'd like to see exhibited on the roadway environment in keeping with a natural created situation. So throughout this project, both in the field and in the simulator, we were really trying to answer the two questions that I outlined earlier. So how does the clear zone size and how does the vegetation density affect driver behavior? So, you know, as we manipulated the clear zone size, so taking it from a small clear zone all the way up through a large clear zone, or as we manipulated the roadside vegetation, you know, taking it from a sparse vegetation or virtually no vegetation all the way up through a dense vegetation, what was the impact on the driver behavior? And as Cole has explained here, the driver behavior was really categorized in lateral positioning, speed, the speed at which the driver operates, and we were also looking at their glance patterns just to see if where they were looking changed as a result of what was happening on the roadway. Now, it would be really cool to look at things like psychomotor characteristics in terms of, you know, drivers' conditions as they're driving, but that was a little outside the scope of what we were doing. Well, what we found was that the roadside trees do, in fact, calm speeds. And so that was in line with our original hypothesis, and we did see evidence to suggest that. The clear zone signs Oh, okay. I think I'm back now. I just got muted there for a second. Maybe that's my cue to stop talking, I guess. So clear zone influenced the drivers more than the vegetation density. All along we had suspected vegetation density would play a role here, and the reality was at the end we did not see that to be the case. The vegetation density didn't change the behavior in any way. It was really a function of how close the vegetation was to the roadway and not at all about how sparse the vegetation was or what the effect was. And then given the effect that we did see on speed, it also identified some opportunities for things that we were already planning to look at, but wanted to think about in maybe a slightly different context. And so it led us to two really different things. Build models to predict crash rates using roadside design as an input. And what we're talking about here, or what the work that we're currently doing, is taking not using the driver contributing code from a crash report form, but rather using all of the variables associated with a particular crash, and then working to identify the extent to which that crash may have been attributed to speeding. And part of the process by which we've done some of this is through a logistic regression model, where we compared the attributes of a crash and then cross-referenced that with the narrative of a crash report so that we could refine the model to determine the extent to which it was working. I'll save that one for a later date. We can have that conversation moving forward. But the initial results are somewhat positive. So the other thing that we wanted to do was look at a quasi-naturalistic driving study using instrumented vehicles. And really, naturalistic driving is certainly the gold standard. And one of the things that we've been doing more recently, or using in a lot of the work that we do, not sure if people are familiar with this app or not, it's UBPix. So UBIPIX. It's an incredibly valuable resource that was developed by some of our colleagues over in Ireland. And the image that you see here on the left side of the screen is a UBPix output. And so what reports back to you is both your GPS, your coordinates, gives you a video of what you're looking at, and then across the bottom and in sequence with the other two fields, it provides you with your speed as well as your elevation. So you get a sense of whether people are going down a grade, up a grade, as well as what their speed is at various points. And you're able to tag and sync the video so that you can identify particular roadside hazards. So, for example, if we were using this video, we could identify when the clear zone matched to certain conditions, and we can record the speeds over that time period. And what you see here on the right-hand side is just a graphic where we were sort of taking this idea and putting it into a proof of concept. And so what we had done was we went out and identified a couple of roadway segments, and we used what we would traditionally use for our speed data, including both ATRs and LiDAR data, and then overlaid the constant UBPix data for a series of drivers and looked at the range, the 85th and 15th percentile speeds for those drivers. And really, what you're seeing here is what we think is pretty consistent and exciting results, in that it shows that this continuous speed data will allow us to study what's happening on the roadway at various points, and then when we consider the video, that will allow us to take a look at what's happening as a function of the other roadway attributes. So some things that we're currently working on. I guess just to wrap up, I know I spent some time when you all couldn't hear me talking about sort of how SaferSim was born, and the idea really being that it's human factors and industrial engineering mixed with the traffic engineering world, and it's really been successful in the sense that it's provided a mechanism where the psychologists are working alongside the engineers, the industrial engineers are working alongside the computer scientists, and it's been incredibly productive. And as a result, a lot of the projects that you'll see throughout the consortium at SaferSim are really applied. In my opinion, they're very applied projects that translate to really real-world scenarios that are of interest. So these are just some of the ones that are ongoing here at UMass, including a bicycle infrastructure project, toll plaza configuration. We're looking at a couple different aspects of roundabouts and cross-sectional design, thinking about vehicle automation, flashing right turn arrows, left turn clearance associated with flashing yellow arrows for left turns, auxiliary speed lanes, or through lanes, and speeds on curves. So if they do have any interest, by all means feel free to follow up with myself or Cole afterwards, and we'd be happy to talk to you about any of the activities that we currently do have on way. The other thing that I was going to say is this year we are also hosting the 2016 Northeast Transportation Safety Conference. For those of you that may be in the area at the time or would love to join us, we'd love to have you. It's going to be a great program. It's Towards Zero Death is the theme, and it's a really excellent program that's been assembled. You can check it out online. Here is the save the date information that went out. You can check out the website. It's the first week of June. It's going to be hosted here in Western Massachusetts, just down the road in Worcester. And with that, you've got contact information for both Cole and myself, and I'll apologize once again for some of the technical difficulties at the outset. But like I said, our plan was to keep it to 20 minutes, and we'd be happy to answer any questions that you might have. I see that Cole has been answering a couple of different questions along the way on the chat, but maybe we can go ahead and unmute folks, and we can answer any questions that you might have. Or if you feel more comfortable entering into the public chat, we'll monitor that as well.
All guests have been unmuted.
Lena, thank you for asking, or Lynn, thank you for asking the question.
So I guess I'll just answer Lynn's question publicly. It'll be easier for me here. So she's asking what these module numbers mean. So in this situation, the first module means the first module that the driver experienced. So this isn't linked to a specific roadside configuration, but rather this was just the first one they experienced. And then in this situation, because it was the first one, they were still becoming familiar with the simulator apparatus, so they looked at their speedometer more often than by the time their experimental drive had wrapped up. So I hope that answers your question, Mike.
Other questions?
Hi, Mike. This is Dawn at the University of Iowa. And I'm wondering if you could talk a little bit about the time of day, day of week, or weather, and how you think those factors might affect some of these speed decisions by drivers. I know it was controlled in the simulator, but there you go.
Yeah, no, that's a great question, Don, and as you suspect, and we suspect as well, certainly time of day, day of week, and several other factors certainly influence that, not the least of which is the weather. Your point's a good one. One of the things that we did initially was to not allow those things to enter as a variable. So in designing the initial wave of experiments, we were always picking consistent times. We were always picking consistent weather patterns, and obviously in the simulator environment that was idealized. But to get at what you're talking about, one of the things that we're currently doing with the speed study that I was just talking about is looking at the variability of driver speeds across a couple of different platforms. And here's what I mean by that. We're looking at, so we've instrumented a series of vehicles, and we're looking at a particular driver's speed on the same road over a number of days. So, for example, if one were to drive a road, let's say 10 days in a row, how consistent is their speed profile along that particular roadway, and what amount of variability exists? But then we're also, so that's variability within themselves across different time periods. Then we're also looking at the variability that exists across different drivers. So, for example, on that same stretch of road, how might my speed profile be different than your speed profile, for example? And then if we go one step further and transfer that to other roadway environments, how does your speed profile, am I consistently traveling at 5 miles an hour faster than you, or is there no predictability that's associated with the speed selection that people are working towards? And that's really what we're trying to work towards, is isolating the variables so that we can bring them all back together and have a more comprehensive selection of that speed selection process as it relates to the roadway environment.
All right, so I'll just jump in and ask a question that Stephen asked in the chat. So he asked if we looked at how the vegetation affected the eye movement. So yes, we did. And we didn't include it here because our samples simply weren't large enough. But what we did was we looked at the horizontal scan pattern. So when the clear zone was large, our drivers scanning a larger field of view than maybe when the clear zone is small. And this may have implications either on side roads or possibly wildlife or other situations, perhaps pedestrians. But simply our sample sizes weren't large enough to make any meaningful conclusions, so we didn't include it here.
There's another question from Ken here asking if we intend to look at vegetation control work being conducted on the roadside and driver's reaction. Just to make sure that I understand the question correctly, you're referring specifically to lawn mowing applications or work crews that are temporarily out there that may be out there on the roadside. It's not something that we've looked at this point, but certainly something that I think would certainly be worth looking at. Or if you're referring more perhaps to different strategies to manage it, and for example, on a particular roadway, winter months versus summer months when vegetation changes on the same roadway, that's certainly something that we'd love to look at in the current study.
Yeah, I was thinking, what could there be a relation to where the placement of
Oh, I think you got cut off there, Ken. So I think I got what you're hinting at. The idea that what happens to placement of different vegetation, and could we more strategically optimize the placement of our vegetation to sort of control the roadway outcomes. Certainly not a stage that we're at right now, but certainly something that we're pretty confident that you know, folks would be able to get to, sort of to optimize that configuration. And then I think there'd be a really fascinating question that kind of gets to, we thought there would be more of an effect by the type of vegetation, or, you know, and that was sort of what we were going for with the sparsity versus the denseness of the vegetation. We haven't seen any proof of that yet, but I've got to be honest, I still think that exists.
So I'll jump in quickly there. There has been some simulator studies that looked at placing trees in suburban settings for the purposes of traffic calming. And they did show a speed reduction simply by adding roadside trees, if that's at all relevant.
And yeah, no, Ken, I think your point's a good one here. Also the idea of reducing maintenance worker exposure to make it safer for operations for employees and drivers. Certainly something that warrants discussion and consideration. Not something that we looked at here, but that certainly could be a result or an outcome. Are there other questions? Well, I think I would go ahead and give the same disclaimer that I tried to give in the outcome or the intro. So I don't know if folks heard it or not, but anytime you're in the area, by all means, feel free to stop by and check out some of the things that we have underway. But sort of with that same, open offer, if you have any follow-up questions related to any of the work that we presented here today or that we have ongoing, please feel free to email myself or Cole. We'd be happy to chat with you and talk further about some of the things. If you think we're failing to ask some of the right questions, we'd love to get your thoughts on questions you'd love to see us ask. But we're pretty excited about the direction that some of this initial work is going, and thank all of you for taking the time out of your busy schedules to join us this afternoon. And thank you, Don and Kathy, for the opportunity to present on the SaferSim webinar series.
Thank you, Mike. Thank you, Cole. I see your contact information is up. I hope people do contact you with questions, thoughts, and comments about your work that you've done and possibly future work. Thank you, everybody, for attending, and we'll be signing off.
Excellent. Thank you.